Hello, welcome. This is a video on how to solve quadratic equations from factored form. And this one is at the highly proficient level. And so it's a word problem. A lot of students get afraid of word problems. Don't be afraid. This is something you can totally do. But it does help to draw a diagram. So it says the length of your garden is 3 feet more than the width. The area of the garden is 28 square feet. What are the dimensions of the garden? So our garden's a rectangle. And we're going to just draw out, what does that rectangle look like? It doesn't have to be perfect, so don't worry about it being perfect. It's fine. Just a quick diagram so you can kind of put your thoughts on it. The length of your garden is 3 feet more than the width, and we don't know what the width is. So let's use W to represent the width. That means the length, being 3 feet more, would be W plus 3. And then it says the area of the garden is 28 square feet, and the area is what's inside. So I've got 28 square feet is the area. And area is length times width. And so one equation would be the width times the length with W plus 3 equals 28. And you could write that. That's one of the equations you could write in here. Write your equation. Well, that's an equation. But we can't solve it like that because we don't have a property for 28, but we do have a property for 0. So what I'm going to do is I'm going to multiply. W times W is W squared, just using the distributive property. Or W times 3, and that'd be 3W. And this is all equal to 28. So I'm going to subtract 28 from both sides. And that will give me 0 on the right. But now on the left, it gives me W squared plus 3W minus 28. And now I can factor that and solve it because I can use the zero product property now that it is equal to 0. So I'm going to say my A is 1. When there is no number, we know that's 1. So the C is negative 28. So A times C, negative 28. And B is 3. And so looking for numbers that multiply to AC but that add to B. And so I'm just going to list them out. 1 times 28 and 2 times 14. 3 won't go into 28, but 4 goes in there 7 times. And then between 4 and 7 are just 5 and 6, and neither of those go into 28. So those are the factor pairs. But because it's negative, one of these has to be negative, and they have to be negative in such a way that when I add them, I get a positive value here for B, which is positive 3. So I'm thinking 4 and 7, and if I put the negative on the 4, negative 4 times 7 is negative 28, but negative 4 plus 7 is 3. So those are the numbers that I'm looking for. So here I can put this in my box and say, here's W squared minus 28 minus 4W and plus 7W using that 4 and that 7. Excuse me, the negative 4 and the 7. And then I factor out, I get a W here plus 7W here minus 4. And so my factors are W minus 4 times W plus 7, and this is equal to 0. And so then I want to say, because these two things are now being multiplied to equal 0, I can say W minus 4 equals 0, or W plus 7 equals 0, and adding 4 to both sides here. Cancels, gives me Y equals 4, and subtracting 7 to both sides here. Cancels, Y equals negative 7. And at this point, I can say, on my ruler, on any ruler, there's no negative numbers, only positive numbers. And so negative 7, we can just say, hey, you don't work here. Only W equals 4. And so at this point I can say that my width equals 4. And then I go back. This is, if my width equals 4, my length is 3 more, so that's 4 plus 3, or 7. And so my length is 7. And so to go back here, I didn't exactly fill in what was my equation. It could have been this. It could be this. It could be this. Any one of those would be fine. But we'll just go ahead and start with the top. W plus 3 equals 28. And you just have to remember that this is our goal. For trying to solve quadratic equations by factoring, it has to be equal to 0.